Lesson 6.5 is on finding the percent of change, which that can either be an increase or decrease. Obviously, if it gets bigger or it started smaller and we have a bigger amount, it's going to be a percent of increase. Or if we have our original amount and then it got smaller, obviously that's a percent of decrease, okay? So they both fall under percent of change. It's either going to get bigger, increase, or smaller, decrease, okay? We will also find the percent error in this lesson, okay? And we'll kind of briefly break down each of those ideas, all right? So for percent of change, all right, you're gonna take your big number minus your small number, all right? And then you're gonna divide that by whatever the first number you were given, okay? Or like the original amount, all right? So in this case, let's say we had something that was 10 inches and it went to 25 inches, okay? And our job is to find the percent of change. First, we can determine, is this a percent of increase or a percent of decrease? Well, it started at 10, went to 25, that got bigger, so it's obviously a percent of increase. And then now to actually find the percent of change, we can put it into our formula, big number minus our small number, and we'll divide it by our first or our original number, okay? So here my big number is 25, the smaller number is 10, so 25 minus 10, and then we need to divide it by the first number. Now the first number I had was 10. Okay, 25 minus 10, 15, divided by 10, okay? Now, there's a couple different ways we can go about this, and we have learned both of these steps in previous lessons of this chapter, where we take a fraction and we make it a percent, okay? We can try mental math, where we ask ourselves, what can I do to 10 and multiply it by a number to get to 100, right? Because we know anything over 100 is whatever that number is on top as a percent. Or we can just divide our two numbers, right, to get a decimal, and then move that decimal over 2 times to the right. Now, in this first example, I'm going to show you that mental math step, okay, which you could divide if you wanted to, but in the next example, I'm going to show you the division, so we hit both of those strategies, okay? I see 15 over 10. I know, hey, I know I can take 10 times 10 to get me 100, because that's the number we want down here is 100 when we're working with percents and fractions, right? So I need to also take 15 times 10, and that's going to give me 150, okay? And I know 150 over 100 is just 150%, okay? So from 10 to 25 inches, that was 150% increase, okay? All right, next example. Say we had 57 people and we went to 65 people, okay? So I'm gonna try to find the percent of change. Once again, if I started at 57 and I went to 65, that got bigger, so this is an increase, okay? Now to find the actual percent of change, I'm gonna take my big minus my small again, which in this case I have 65 as my big, 57 is my small, and I'm gonna divide it by the first, which was 57, okay? So 65 minus 57 is gonna give me 8 over 57. So 8 divided by 57. Now here I can't really take 57 times anything to get to 100, so then I have to revert to dividing these two numbers to get a decimal, which then I can later change to a percent. So we always put our first number on the inside and our second number on the outside, okay? When we are doing these today, all I'm asking you to do is to get to 3 numbers after the decimal, because it's gonna ask to round to the nearest tenth of a percent, okay? So if we have to divide and it still hasn't come out nice yet, once we get to 3 numbers after the decimal, we can be done and we can stop, okay? So here, 57 goes in 8, well it doesn't, it's too big, 0 times. So I need to add my decimal, bring that up, and 0 goes down. Now 57 goes into 80 one time. So I'm gonna put 1 here and 57 here. Subtract. And we need to bring down our next number, okay? Now, 57 is gonna go into 230 4 times. 57 times 4 is 228. Now, if you're not sure on that, you're just gonna have to guess and check. You know, take 57 times numbers to try to figure out what can get you really close to 230, all right? And 57 goes into 20, 0 times, okay? So here I have 0.140, right? Or kind of like 140 thousandths. So that is my decimal. That's not the objective here. Our objective is to find the percent. So what we need to do is take that decimal, and we've learned anytime you make a decimal a percent, you move it 2 times to the right. So 1, 2, so that's right after the 14. So it is 14.0%, and it was a 14% increase, okay? So once again, you only need 3 numbers after the decimal, so after we move it over twice, I still have a number in the tenths place, and that's what it's gonna ask us to round to today. So 14% increase. All right. Now, percent error, okay? Percent that an estimated quantity differs from the actual amount, okay? So what you're gonna do is you're gonna find the amount of error. So what you're gonna do is subtract what the actual amount and the estimated amount are, and then you're gonna divide by what the actual amount is, okay? So here, you estimate that the length will be 16 feet. The actual length is 21 feet. Find the percent error, okay? So what the actual amount was 21, and what you estimated was 16. So you need to subtract kind of big minus small again on that, all right? So 21 minus 16, that's gonna figure out the amount of error. How far off were we on our prediction? Then you're gonna divide by the actual amount. Now, it's not always the first amount when we find percent of error, it's the actual amount. And here it said the actual length is 21 feet. So in this case, we divide by 21, okay? So now we need to take 21 minus 16, which is 5, divided by 21. Now, I can't really do mental math with 21 and multiply it by a number to get to 100, so we just got to divide again to get a decimal, which then we will later change to a percent. Top number always goes on the inside. Okay, so 21 goes into 5 0 times. We add our decimal and our 0. 21 goes into 50 2 times. 42, subtract, I get 8, and we bring our 0 down. 21 goes into 80 3 times. 21 times 3 is 63. And then we need one more number. 21 goes into 170 8 times. And 8 times 21 is 168. All right, so after we have 3 numbers after our decimal again, we can be done dividing, right? Because when we move our decimal to make it a percent, we will already have a number in the tenths place, okay? So I have 238 thousandths, so what I need to do is just move my decimal 2 times to the right to make it our percent, which would be 23 8/10% error, okay? So percent of change, big minus small, divided by the first, right? And then you need to tell whether it's an increase or a decrease as well. Just look at, oh, did the numbers get bigger or did the numbers get smaller? And then percent error, you take the amount of error. So how far off was your estimate compared to what it actually was? So you subtract those 2 values, and then you divide it by the actual amount, okay, on the percent error. Make sure you have a label as percents today, because every question will be asking you what the percent of, either change or error is. All right, on page 244, 4 through 18 evens, and then you will do number 25.